Hello class. Today we're going to go ahead and look at section 4.5, complex numbers. We're going to spend 2 days on section 4.5. The first day we're going to go ahead and look at the properties of square roots, and then the next day we're going to actually look at complex numbers. So the first two properties are the product and the quotient rule. So the product and the quotient rule. So product means multiplying, quotient means division. So this first one listed here is our product rule. If I have the square root of a times b, I can rewrite it as the square root of a times the square root of b. The next one is my quotient rule. If I have the square root of a over b, I can rewrite that as the square root of a divided by the square root of b. So one example is if I have the square root of 16. I know the square root of 16 is 4, but another way to think about it is I can write 16 times is 4 times 4. So I could say, well, the square root of 4 times the square root of 4, breaking it apart. Well, the square root of 4 is 2, the square root of the other 4 is 2, so 2 times 2 is 4. There's one way to think about the square root of 16. One way to rethink the quotient rule is if I have the square root of 49 over 81. So I can say, well, it's the square root of 49 divided by the square root of 81, which gives me 7 over 9. Okay. One reminder is that simplified square root expressions do not have radicals in the denominator, so no square roots in the denominator. And any number underneath the square root sign has no perfect square factor other than 1. So make sure you factor everything out. So something that you will really will help succeed through these problems is knowing the perfect squares. So just to start a list, if you wanted to, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and you could keep going all the way up. 16 times 16 is 256, so all of the numbers listed in the red are my perfect squares. So let's look at an example. Breaking down radicals into simplest form is essential when you are using the quadratic formula. So that's why we're doing this now, because we are going to do the quadratic formula next. So we need to simplify our square roots. So what I do is I have my list of perfect squares here off to the side, and I think, what perfect square is in 50? Well, 25 times 2 gives me 50, so I say, well, the square root of 25 times the square root of 2 will be 5 square root of 2. Then I go ahead and I look at b. Well, I say, what's my perfect square in 45? 9 times 5. Square root of 9 times the square root of 5. Well, square root of 9 is 3 times the square root of 5. And there we go. Simplifies to 3 times the square root of 5. Now I want you to go ahead and try C and D on your own. So go ahead and pause the video and try C and D on your own. All right, if you go ahead and look at C, there's two different ways to think about it. I have the one off to the left in black ink and the one to the right in the red ink. One way is 64 times 2 gives you 128, and also 16 times 8 gives you 128. So I worked out both ways of thinking about it. So go ahead and look at that. Part D, I just want you to recall that the square root of x, or the square root of anything, really means x to the 1/2 power. Okay, so if I look at D, it's really x squared to the 1/2 power. So I'd have 2 times 1/2, which gives me, well, 2 times 1/2 is 1, so x to the first. So that one simplifies to x. If I go ahead and move on, part E, go ahead and break that into parts. So I would have the square root of 25 times the square root of x squared times the square root of y to the 4th. Well, I know the square root of 25 is 5, and the square root of x squared is x. Now, this y to the 4th, same thing. If you need to, y to the 4th to the 1/2. I would be taking 4 times 1/2. Well, that gives me 2, so it's y squared. Essentially, if you're taking the square root and it's even, you just divide it by 2. So here is part E simplified. Let's go ahead and look at F. It is the square root of x squared over x. It's division, so I can break it apart. Square root of x squared divided by the square root of x. When I do that, I would have x over the square root of x. It's not proper, or it's not simplified, to have the square root of x in the denominator. So what I'm going to do is I'm going to take and multiply by the square root of x over the square root of x. Whatever is here, I'm going to multiply by the same thing here. And this is going to be okay because the same number over the same number is 1, and you can multiply anything times 1. So this equals, and I go straight across, so I have x square root of x over the square root of x times the square root of x. So one thing we can do is in the denominator, I can rewrite those both underneath the square root sign. And then if I go ahead and combine them, I would have the square root of x squared, which we just got done talking about, is just x. Then my x's will cancel, and I am left with the square root of x. So f simplifies all the way down to the square root of x. Let's go ahead and look at g. Okay, g is division, or the quotient. So I'm going to go ahead and break it apart. Square root of 11 over the square root of 49. Square root of 11 does not have any more perfect squares in it, so it's just the square root of 11. And the square root of 49 is 7. That one is all simplified. There's no radicals in the denominator, so I am good to go. H. If I go ahead and look at that, once again, I break it apart. Square root of 32 over the square root of 81. Well, 32, I think what perfect squares are in 32? I know 2 times 16 is in there. And then the square root of 81 is 9. So I have the square root of 2 times the square root of 16 over 9. Square root of 16 is 4, so I have 4 square root of 2 over 9. And that is simplified as far as possible as well. We have one more example that we are going to look at today. It's right here. J. So we have square root of 32x over the square, or over 8. So break it apart. 32x over the square root of 8. Once again, we just did the square root of 32. So that's going to break down times 16 times 2 times x all over. My perfect square in 8 is 4 times 2. So I would have the square root of 16 is 4. Underneath the square root, we can't take the square root of 2 or x, so we leave it as is. And then the square root of 4 is 2, and then I still have this 2 underneath the square root sign. So I simplify. 4 divided by 2 will give me 2. Square root of 2x over the square root of 2. Can't have the radical in the denominator, so I multiply by the square root of 2 by the numerator and denominator. So what I get here is I have 2, and then I would, underneath my radical, I would combine these. So it'd be 2x times 2 will give me the square root of 4x all over the square root of 2 times the square root of 2. So I would have the square root of 4. This gives me 2 times, well, the square root of 4 is 2. Square root of x all over the square root of 4 again is 2. So this will cancel, and I am left with 2 square root of x. And that is, I simplified. So we're going to go ahead and stop the video there. We will look at the square root property tomorrow in class. And you have a nice evening. I will see you tomorrow.